Welcome to the Deep Dive. If you work in design, engineering, or construction, you probably know the biggest success factor isn't always the budget, maybe not even the timeline, but uh, really how well architects and engineers actually talk to each other. Today, we're digging into sources describing what looks like a really significant shift happening right now. This powerful fusion of artificial intelligence, AI, and building information modeling, or BIM.
And that's exactly what we want to unpack for you. Our goal today is, well, to cut through the hype a bit and figure out how this tech advancement actually changes the day-to-day job.
Yeah.
Specifically, how it's transforming that, let's be honest, notoriously complex and sometimes error-prone world of design team workflow. We're not just looking at, minor software tweaks here.
Yep.
The sources describe something more fundamental, a real change in predictive power.
That collaboration point you made, that's kind of the whole ball game, isn't it?
Yeah.
Because when those communication lines get, well, tangled,
Yeah.
when an architect's big idea clashes with, say, an engineer's structural reality, that's when the budgets balloon, time just evaporates, and sometimes projects can fail pretty spectacularly.
Definitely.
We're looking at AI here as this really impactful innovation because it seems like it's not just reporting data back. It's actively designed to tackle those age-old, friction-filled collaboration headaches before they even pop up as problems.
Exactly. So maybe let's start by defining this fusion. Because, look, BIM itself isn't new. It's been around for decades.
Right, standard practice now.
But what we're talking about now involves AI technologies, specifically things like machine learning, complex data analytics, that fundamentally give the traditional BIM process new capabilities.
Okay.
So BIM used to be mostly about creating a shared digital model documentation, basically. Now, with this AI layer added on, it moves beyond just modeling to what the sources are calling intelligent modeling.
Okay, that word intelligent, what does that actually mean when you boil it down? Because, sometimes that just means it has a slightly better search function.
Oh, it's much deeper than that. We really need to pull apart the two core technologies here. You've got the machine learning, the ML part, that's the engine.
Okay.
It's learning patterns from, tens of thousands of past projects. Failures, successes, material stress tests, local code variations, all of it. Then you have the data analytics part. Think of that as the scoreboard and the proactive coach.
Oh, okay.
It's the system telling the structural engineer, maybe, hey, this specific column design, it shows an 85% chance of a cost overrun based on similar projects in this climate zone.
Wow, okay, so it's not just showing the ductwork nicely in 3D, it's actually calculating the risk profile of the entire design, like in real time.
That's it, exactly. The AI boosts the model's accuracy and its functionality, making it predictive. It can suggest optimizations, things a human team might easily miss because, frankly, who can process a million variables at once?
Right, things like material cost shifting or embodied carbon impact, even local zoning changes happening overnight.
Precisely. And this fundamentally changes the architect's and engineer's job. It moves from just designing and double-checking to more like managing this intelligence process, working smarter, really, not just harder.
The sources we looked at do a pretty good job breaking this huge transformation down. They really spotlight three specific areas where AI is, well, changing the game. It structures the discussion quite clearly for us. The first one, and maybe the most critical, is predictive design enhancements. And I was struck that the sources put prediction even before efficiency. Why is that foresight aspect seen as the biggest benefit right now?
Well, because that's where the most value typically gets lost, right? In the old way of doing things, design problems often don't surface until the drawings are almost done, or even worse.
They start building, yeah.
Exactly. Predictive design uses that huge ML analysis, past projects, material performance data, regional risks, maybe even local soil reports to spot potential conflicts and suggest fixes really, really early. And that minimizes the cost of changes, which, as you know, just explodes the later you find them.
So it's not just finding like a pipe hitting a beam. It's finding systemic risk baked into the design strategy itself before you've even finished the detailed drawings.
That's a great way to put it. Precisely. Then, if we move to the second benefit, increased efficiency. This is more about the automation side.
Okay.
We're talking about automating routine tasks, but also complex, high-volume ones. The AI can handle certain design adjustments, those repetitive coordination checks. The stuff that often eats up a junior architect's or engineer's time.
Right, which means the hours and hours previously spent manually tweaking dimensions or checking every minor structural detail against the code, that time gets freed up.
Mm-hmm.
It really changes the skill set needed, doesn't it? Instead of 2 weeks on manual revisions, maybe it's 2 hours reviewing the AI's suggestions and just confirming the overall strategy.
That's the real efficiency gain. It compresses the time needed to agree on things and make decisions just by taking away a lot of that tedious data crunching.
Okay, and the third benefit, this brings us back to where we started, improved collaboration. But hang on, collaboration tools aren't new. We've had shared platforms for years. How does AI specifically fix those tangled communication lines we mentioned? Is it just fancier version control?
It's way more than just version control. It's active intervention. Think of it like this. AI-enhanced BIM makes sure every single team, architecture, structural, MEP, you name it, is working on the exact same digital twin
Okay.
in real time with this layer of continuous intelligence over it. So when the architect shifts a wall slightly,
Yeah.
the AI can immediately flag the structural model, maybe recalculate loads, and alert the engineer about a needed beam adjustment before the architect has even finished saving the file.
Wow. Okay, that speed and that shared intelligent platform actively cut down errors across disciplines, right?
Yeah.
It prevents those silos where one team makes a change and nobody else finds out until the next big coordination meeting, maybe weeks later.
Exactly.
Yeah.
Here's where it gets really interesting, actually, because we can look at some specific applications where this AI BIM fusion delivers, tangible results. It's about more than just going faster. It's creating this unified predictive space for making joint decisions through the whole project.
Okay, like automated clash detection. That used to be the absolute nightmare of pre-construction, didn't it?
Oh, yeah.
That, painstaking process of overlaying drawings from different teams and spending late nights hunting for where the HVAC duct goes right through a main column.
Anyone who spent a Friday night on site trying to figure out why a structural beam is suddenly clashing with a newly routed pipe run,
Yeah, they don't miss that old manual grind.
I bet.
The AI version does two things the old way just couldn't: speed and scale.
Yep.
It automatically spots conflicts across maybe hundreds of thousands of components in minutes, not days or weeks.
Minutes. Wow. And crucially, it's not just finding physical overlaps. It can identify conflicts based on complex rules, clearance requirements, material no-go zones, even installation tolerances.
And the impact, as the sources really stress, is immediate. Right? It flags the issue to both the architect and engineer at the same time, maybe even suggests solutions
Often, yes.
before construction starts.
Yeah.
That saves just incredible amounts of time and money that would otherwise get burned fixing problems on site.
Then there's sustainable design optimization. This one, I think, really shows the power of machine learning because it moves beyond just fixing errors to actually creating significant value.
Well, so.
Well, traditional design teams, they rely on standard codes, best practices, maybe some rules of thumb for sustainability.
Right, but the AI tools, they can chew through massive data sets simultaneously. Things like materials, energy use, environmental impact. Give us an example of the kind of depth here that a human team just couldn't manage.
Okay, so the real power isn't just checking against existing standards. It's running like millions of tiny simulations. A human team might compare, say, 3 different options for exterior cladding.
Standard practice.
The AI, it could calculate the embodied carbon footprint of 50 different materials from various suppliers, factoring in real-time supply chain issues, fluctuating energy costs in that specific region, even predicting how different materials perform under shifting weather patterns over the building's entire 50-year lifespan.
Whoa.
It essentially acts like a super-powered sustainability consultant modeling performance under countless future scenarios.
That's a massive difference. It means the design isn't just optimized for cost or structure, but for actual provable long-term environmental performance.
Yeah.
That's a huge selling point for clients aiming for net zero or similar goals.
Absolutely huge. And the thing enabling all this seamless back and forth is real-time collaboration. This is really driven by these cloud-based AI-powered BIM systems because the intelligence, the algorithms, the massive data sets, they're all hosted centrally. So architects, engineers, consultants, they can all access and even edit the same models at the same time.
Simultaneously.
Yes. Which really cuts down friction and allows for genuine interactive design sessions, not just trading static files back and forth and waiting days for updates.
That connectivity must really break down the old rigid structure of project phases, allowing more fluidity and speed.
Yeah.
Like the engineer doesn't have to wait for a finished design package to start analyzing. They're analyzing as it evolves.
Getting rid of those disciplinary silos,
Yeah.
that's been the dream for complex projects forever, right? These cloud-based AI systems feel like they could be the final nail in that coffin.
Okay, let's unpack this a bit, though. Because, like any huge tech leap that promises the world, this isn't frictionless, is it? We can't just talk about the benefits without looking at the challenges or considerations for actually adopting this stuff.
Yeah, the sources we read were pretty down to earth about the adoption curve. They generally pointed to three main hurdles. The first one, no surprise, is investment. The upfront cost for these AI-enhanced BIM tools is significant, yes, but it's actually more than just the software licenses.
That's what I was wondering. What else goes into that investment beyond just paying the subscription fee?
Well, for a lot of established firms, it can mean a complete infrastructure shift. You need serious computing power, right? Often that means investing in dedicated high-speed cloud infrastructure just to run those complex ML algorithms and the simulations we talked about.
Right, that makes sense.
Plus, there's the often hidden but intense cost of just integrating these new systems with all the firm's existing software, their databases, their internal workflows. It's often an overhaul, not just installing one new program.
And the second challenge seems directly tied to that.
No.
Personnel. You need highly skilled people to run this tech.
Yeah.
It's not enough anymore to just be a really good BIM modeler.
The skill set is definitely shifting quite dramatically. Firms need specialized folks, people who can understand the algorithms, make sense of the complex data coming out, and, this is critical, know how to prompt the AI effectively to get the best results.
So less technical drawing, more AI strategy.
Kind of, yeah. We're moving from needing primarily technical drawers and modelers to needing people you might call AI strategy managers or design data interpreters within these firms. So investing in some serious continuous training or hiring completely new kinds of talent, that's a massive hurdle for many.
And finally, the perennial issue, always thorny in any connected digital world, data security. When you're sharing and processing proprietary designs, client secrets, maybe even the firm's own unique algorithms across these shared cloud platforms, the risks seem to multiply.
They absolutely do. And the worry isn't just about a basic data breach like someone stealing contact lists. It's about exposing sensitive client intellectual property or even the firm's competitive edge, the way they design their specific methods learned over years.
Right, their secret sauce.
Exactly. So the systems need incredibly robust protection, and the whole legal side of data sharing, especially across international design teams, needs very careful thought.
That makes the adoption barrier feel less like just a tech problem and more like a big strategic business risk that needs careful management.
It is. The risks are definitely proportional to the potential rewards here.
So as we wrap up this deep dive, the overall promise of mixing AI and BIM seems undeniable. It looks like it's creating a more efficient, definitely more predictive, and hopefully a much more collaborative environment for everyone involved in designing and building our world.
It's definitely being described as a key driver of innovation, and for good reason. This ability to optimize designs using millions of data points, to streamline workflows by automating the complex stuff, and crucially, to proactively stop those costly mistakes before they happen. It means teams really can deliver higher quality, more sustainable projects reliably on time and, importantly, within budget. It feels like the end of design being just a linear, error-prone sequence.
Which brings us right back to those challenges we just discussed, the investment, the need for skilled people. If AI-enhanced BIM really does streamline workflows so effectively and prevents those huge, expensive mistakes, the site disasters, the total redesigns halfway through, how quickly do you think the demand, the financial incentive for people who can manage these systems will overtake that initial investment cost in the next few years? What specific skills should you be focusing on learning right now to be ready for this increasingly intelligent, predictive future of design? That's definitely something to mull over until our next deep dive.